On this video, I will be explaining the microwave protection circuit. Um, whether you call it a filter or whatsoever, they all the same. When you open a microwave, you will get a same protection circuit. This circuit is the same to this one, and it's also the same for this one. I don't remember this one is Samsung. I don't remember where I took this one and this one, but they all the same. The only thing that may vary is the capacitance and the the resistance. So this is what they do. Any microwave, when you plug it, the plug supplies live, neutral, and earth. So what the filter does is, we know that live will always go to the fuse. I call this a protection circuit for a reason. So when we look at this circuit, at least this one it's written N and that one it's written L. So it tells us where to put live and where to put neutral. Let's look at this one. They all telling us, but let's say we didn't know. So we know this is where the fuse goes. So we know we should either plug here or here. So when we flip at the back, this is the fuse. So this portion is isolated to this portion. It's only connected when we put a fuse here. So we know that here we will be plugging. So if this is the fuse and it's the same portion, that means live goes here. So we have live, then to the fuse, then the fuse will connect us to this portion. So what is this and what is this? Let's flip this around. It's a capacitor and an inductor. So we know that this is a capacitor, this is an inductor. So our drawing continues. It's a non-polarized capacitor in parallel to an inductor. So let's stop there, because we said live, fuse connectors here, then the capacitor, then the inductor, then the inductor again. So we know that in this inductor is not alone here, it's connected to this. What is that? That is the resistor. So we've got a resistor connected. So again, live, fuse that connect us here, capacitor, inductor. Here it's isolated, then our inductor completes here, then the resistor. From the resistor, where do we go? What's there? Let's check. That's the output. So this one is not connected to that one. What is this? This is the capacitor. Okay, this capacitor connects us to this portion. What is this? This is earth. So from the resistor, from the inductor to the resistor, then here to the capacitor, and there to the output. So here, let's connect this capacitor like that. I will tell you why. This is the capacitor, and then here is the output out. So we were only working on the live side now. Now let's come to the neutral side. So neutral will get in here. Neutral is connected to the capacitor and the inductor. The capacitor and the inductor. So that is our neutral connected to the capacitor, then an inductor. So this inductor, oh, that is the live side, sorry. That inductor is then connected here to the, what is that? The resistor. It's connected to the resistor. So the resistor. So we are there. Let's continue. Neutral also gives us an output. Neutral is also connected to the capacitor at the back. This capacitor goes to earth again. So we also have an output. We also have the capacitor. So this capacitor is grounded, and that capacitor is grounded to the earth. So all circuits, all microwave circuits, they are the same. I'm gonna show you what I mean by that. This is the protection circuit for another one. The fuse go here, so let's check. If the fuse goes there to here, then that means this is our live. So we put live here, and then the fuse connects us here. What is happening here? We are connected to there and there and there. Let's check what's there at the back. Okay, that one is the resistor. This one is the capacitor. So let's draw also this diagram. Live, neutral, earth, fuse. Okay, we said the fuse connects us to the resistor and the capacitor and the inductor. So we've got the resistor and we have the capacitor and we have the inductor. So the resistor, the capacitor, the inductor. So now, where is this inductor? Okay, here is the inductor. Then this inductor gives us an output here. So this inductor is connected to this pin that gives us an output. So let's say this is out. Now, where is that capacitor? We said this inductor is connected to this output, and here is this capacitor again. It's grounded. So let's make it here. Cap, which is grounded. So we know what's gonna happen. We were on the live side, right? We're on the live side. So let's go to the neutral side. Neutral, okay. No, this is the live side. It goes like this. Then neutral goes here. Neutral is connected to the resistor. That's the resistor. The capacitor, that's the capacitor, and the inductor. So we know that neutral does the very same thing that it did on the above circuit. Then the inductor. What do we know? We will have that cap grounded. Inductor, output, the cap that is grounded. So we'll have our output, V out, and we will have a cap that is grounded. So what do you see? The only difference here is that the resistor was after the inductor and here it's before the inductor. If you would ask me, I would say that makes no difference because this is a parallel circuit. So this resistor is parallel to this capacitor and to the inductor. So it makes no big difference. It's not a big deal. So we can also check this one. We will not draw this one. This is the fuse, right? So we need to trace where does life go. So if this is a fuse and the capacitor, this is the capacitor, it's connected there. So that means life goes in here, and then the fuse, then out, then the capacitor, then the inductor. So this one is like this one. The inductor, then we've got these two pins here. Let's check. It's the resistor and the capacitor, So we were on the live side. Let's come to the neutral side. We said we went like that. That means now the neutral must be this one, and it's written that's live out. Let's start afresh. The fuse, life goes there, then the fuse. So here it's the inductor. Yeah, this one should be. This one is live out. How is that possible? Oh yes, it's possible. Our live went here, then they went that way, and from here, no, we took the wrong direction. We're supposed to say in, and then we go this side, then live out. That's how the circuit works. Then that means this side, it's our neutral side. So neutral must be this pin. Yes, it's an in. I don't want to look at what is written because I must show that I understand this thing. So this is neutral. Neutral is connected to the capacitor, to the inductor, then the resistor, this resistor. After the resistor, the capacitor. Then this capacitor, they all connected here to ground. So this is another circuit. This is the protection circuit. This is another circuit. So they all the same. Microwave protection circuits, they all the same. Why I call them protection circuits? It's because in the case where this cap blows, let's say this cap blows and make a short, it will blow the fuse. And when the fuse is blown, we'll have to come and check where is the short circuit. On this case, I said it's this capacitor. So the microwave will not switch on. Though inductors don't give us problem, like you see, they have isolated it carefully. This winding to this winding. So let's say if they make a short again, the fuse will blow. If there is a short here, again, the fuse will blow. If there is a short there, we will have an earth fault. The microwave will keep tripping the earth leakage. Same here, it will keep tripping the earth leakage. So this is the process is also all the same to this one. So that is what a protection circuit of the microwave looks like. And for fault finding, it's simple as ABC. Thanks for watching.